All right, I'm going to talk you through six kind of harder U substitution problems. So this is kind of part two, and most of these I'll go through the whole, kind of the whole formal process of identifying U, du, and then making some substitutions. Um, so let's just take a look at this. When you look at a problem like this and you have a square root, it is likely that under the square root is going to be your U selection. So you kind of have this vision here that if u is going to be x squared plus 4, then du is going to be 2x dx. And so you would love to have a 2 there. So put a 2, put a half. The 5 can always be factored out. So it's going to end up looking like 5 halves du over the square root of u, and then you're going to integrate using the power rule. Again, you should have the vision of what's going to happen without having to go through the whole process. Again, we will, but you should be able to see it. So let's go ahead and make u x squared plus 4. Du then is 2x dx, right? And that tells us that dx is equal to du over 2x. Now we'll go and we'll make the substitutions. The integral 5x over the square root of u, and then put in dx. dx is du over 2x. The x's cancel, and again, if they didn't, then you did something wrong. I'm going to go ahead and factor out the 5 halves of the integral. Again, I haven't done the integral yet. I'm just having du over the square root of u. Most of you are probably going to want to rewrite that as the integral of u to the negative half du, and then we can do power rule. Increase the power by 1. Increase the power by 1. Divide by the new power. Dividing by a half is the same thing as multiplying by 2 plus c. The 2's cancel and you get 5 times the square root of u, right? That's u to the half, and u was x squared plus 4 plus c. You can always take the derivative of this and make sure you get this back. And again, if you take the derivative, you're going to take it, bring the power down by 1, which will put the square root in the denominator. You'll multiply by 2x. You'll get an x, and where the 2 go, well, when the power rule happens, you get a half from the power and a 2 from the chain rule, and all of a sudden the 2's are gone and you're left with just that 5. Again, it works. Again, U substitution, probably the hardest part is to identify, okay, what in the world's going on here? It's probably a safe bet to think that it's a power rule when you have a square root, which also means that you probably want to think about making that U. Okay, you look at this thing and you have some exponential. Now you have something times something, but you actually love that x. If this is a quadratic, you need the x out there because eventually it's going to play a role in the du. So let's just guess that this is our u, right? The big rule here is e to the u du. So that means that's our u. So u is 3x squared. That means du is 6x dx, which means that dx is du over 6x. Okay, let's make that substitution. Integral of e to the u, oh, my x, don't forget that x, e to the u, and then instead of dx, I'm going to write du over 6x, du over 6x, the x's cancel, I can take that 6 out and write it as a 1/6 integral of e to the u du, boom, done, because this is a standard. The integral of e to the u du is e to the u. So I get 1/6 e to the u, where u is 3x squared. And this would be a pretty easy one to check the derivative. Take the derivative of this, you're going to get a 6x. 6 and 1/6 go away, and you're left with that x out front. Cool, it works. Again, U substitution, formally it's fine. As long as you get used to the process, you can do this pretty quick of identifying the u, du, make substitutions. And again, what are we doing here? We're taking integrals that have x's and writing them in u's, because once we get it into this form, we can do it. Again, can't do this integral, but once we get to here, well, that's a standard form. We can do that integral. Again, I'm going to do 6 of these, and kind of hopefully you see the pattern. Right, this next one, I have the natural log of x to the 5th over 3x dx. Like, I don't even know what's going on, but I have something to the 5th power. I'm going to probably think this is power rule. So go ahead and make the natural log of x your u, which du then is 1 over x dx, which says that dx is equal to x times du. Okay, let's make some substitution now. The integral and the natural log, that's just u, so that's u to the fifth over 3x times du, but times dx, but dx is x times du, and as always, the x's go away. And again, if they didn't, then we have a problem. They need to, right? 1/3 integral of u to the fifth du. We successfully changed an x integral into a u integral, and the u integral is easy. This is a basic power rule. The integral of u to the fifth du is u to the sixth over 6. So increase the power by 1, divide by the new power. And so this is just 1/18. U to the sixth, and u is the natural log, plus c. Okay? This one's a little tricky because you might not notice this notation is garbage. I hate that they do that. They kind of confuse you. But remember, sine to the fourth of 2x is sine 2x all to the fourth power. So again, it's likely that that is your u. Not 2x, but the big thing. Remember, this is the same thing as sine of 2x all to the fourth times cosine of 2x. And if you think about the power rule, if this is your u, that's going to play a role in the du. Actually, you couldn't do this problem unless you had this. Same thing over here. You couldn't integrate natural log of x to the fifth unless you had that x. That x was part of the du. Okay, go back. U is sine of 2x. So then du, the derivative, the differential of sine of 2x is cosine 2x times 2 dx. Again, you get that 2 from the chain rule. Right? That implies that dx is equal to du divided by cosine 2x times 2. So 2 cosine 2x. And now let's make the substitution. This is the integral of u to the fourth cosine 2x times dx, which is du all over 2 cosine 2x. The cosines cancel as always. That 2 is a half out in front. And then we have a basic integral. The integral of u to the fourth is u to the fifth over 5. So we get 1/2 u to the fifth over 5 plus c. And so we get 1/2. Actually, let's just go ahead and write it as 1/10, right? 1/2 and 1/5 u, but u is sine, and I'll use silly notation, 2x plus c. And again, I think this is pretty predictable. Think about it. If this is your u, if u is going to be a sine, then du is going to be a cosine, but since this is a 2, you're going to need an additional 2 there. So if you put a 2, you put in a half, and all of a sudden you have u to the fourth du, u to the fourth du, u to the fourth du and a half. So I would say that this one is pretty easy to see that if you just manipulated it from the beginning, you could skip all this formal use substitution stuff and go straight to this. I don't care if you do it or not, but you should have that vision that you're going to create that factor of a half out in front. Okay? All right, 2 more. This next one, again, you see a square root, you see some trig functions, you're not really sure what's going to go on. Probably a good idea to make the square root to make that your u. So let's make that our first guess. So u is cosine x, du is negative sine x dx, which tells us that dx is equal to du divided by negative sine x. And let's make some substitutions. Okay, that's sine x over the square root of u times dx, but dx is du all over negative sine x. The signs cancel. I'm going to take that negative sign out in front. So negative integral of du over the square root of u. Okay, some of you should rewrite that. So that's u to the negative half power du. Right? 1 over the square root of u is u to the negative half. And now that's a basic power rule. Increase the power by 1, increase it to a half, and divide by the new power. Dividing by half is multiplying by 2 plus c, so we get negative 2, and u to the half is the square root, and u is cosine x plus c. And again, you can kind of see where the half came from. We're going to square root. You get a negative sign because we had a u and we actually had the opposite of the derivative. So we get a negative sign. Okay, last one. Again, you see something to the cube, probably going to make that u. So u equals x squared plus 2. Du equals 2x dx. That tells us that we can get rid of dx and write it as du over 2x. We can substitute in then. That's 4x all over u cubed, right? U cubed. And then dx is du over 2x. X's cancel. 4 over 2 is just a 2. So it's really just 2 integral of du over u cubed. Again, power rule says increase the power by 1. Increase the power by 1 and divide by the new power. All right, so that's negative 1 over u squared, which is negative 1 over u, which is x squared plus 2. Bingo. Okay? O plus C. So those were 6 kind of u substitution problems. Hopefully you kind of followed all the process, but again, the biggest thing probably is just deciding what is u and then kind of go from there. All of them, it doesn't matter if it's a trig function, a power function, exponential, a logarithm, all of them take x integrals that look confusing and change them into u integrals. And once you get to the basic, again, this is power rule, this was power rule. You can look at the last sheet. We took this thing, again, this was a power rule. This was power rule. A lot of these examples here were power rules because there were some of the more interesting ones that you're going to see a lot, and they involve things. This is our exponential. Again, if you have e to something, that something is probably your u, and then eventually your rule is going to be e to the u du. Most of the time, the hard part is just making sure you get that factor right. You know, that half, that sixth, you know, a 30th, whatever that may be. But hopefully this helped. But again, u substitution is all about taking x integrals, rewriting them in terms of u to make it so that the integral is one of the basic forms. If you can get to the basic forms, you're good to go. Then you just do the integral. If you can somehow cancel an x, and you took an x integral and you have x's and u's, then you have to keep making a substitution. You miss some cancellation, or you might have actually picked the wrong u to begin with. But hopefully this helps you kind of as the second part of u substitution.